Good morning, students. How are you? Have your breakfast? I think your online class is going on in good manner. Watch the online class and be safe in your home and study your lessons well. Okay, I have put the equations of motion in the previous video. Watch that video and continue this video. Okay, okay. Today we are going to see the next topic of motion, that is motion of freely falling body. What is nothing but freely falling body? See here, I have kept a picture. See, a man is standing here and he what dropping the stone as well as the crumpled paper at the same time. But the stone come to the ground first when compared to the what when compared to the paper, isn't it? Why this happened? That we are going to learn from this. Okay, motion of freely falling body. They have kept an activity, that is, see the marked one. A person is standing and he is taking a large stone as well as a small eraser, and he dropped both the thing at the same time, and what he observed. That is the first question. And second question is, and he take a small eraser as well as a sheet of paper, and he dropped both thing at the same time, and what he observed. As and also he take a two sheet of paper and he crumple one sheet of paper. Nothing but crumble is nothing but this is like this manner. He crumble one sheet of paper, and another sheet of paper is in of normal manner, and he drop both the paper to the ground, and which one reach the ground first, and that is need to observe. So from the first activity, what do you think? Which one will reach the ground first? From large stone and small eraser, both the thing will reach the ground in the same time, like second difference, isn't it? Yes. While seeing the small eraser as well as a sheet of paper, the small eraser will reach the ground first. And while seeing the two sheet of paper, but you need to think that the two sheet of paper are of same weight, but one paper is crumpled, so that the crumpled paper will reach the ground first when compared to the other paper. Why? That why is we are going to learn from here. See, if I'm saying a thing that if you drop stone, eraser as well as paper or anything in a vacuum. What is the meaning of vacuum? Vacuum is nothing but there is none of air. There is no air at all. In that medium, the what? All the thing that reach the ground at the same time. All the thing that reach the ground at the same time. If in the air medium, if you drop a thing, in the air medium, the medium have more air. So the air acts as a resistance. What is the meaning of resistance? Resistance nothing but tadai. In Tamil we say tadai. Resistance, so that the free flowing object take some time to reach the ground. Okay, and this free flowing object produce an accelerated motion. It come down, right? The free flowing object, it used to come down like in this manner. It produce this manner produce a accelerated motion, as well as the thing produce gravitational pull. What's the meaning of gravitational pull? Gravitational pull is nothing but in our earth, the center point. See, this is the earth, and the center point have some gravitational pull, and this act all the things that present in the earth make to attract, and we are not moving, we are not shaking like a moon. If you know that Neil Armstrong went to moon and he fly there, he didn't stand there, isn't it? He can't walk there. He want to fly and walk. There is no like Earth, there is no one can walk in the moon. So like that he what like that's because the earth have gravitational pull. So the thing that draw from the top to the bottom, there is more gravitational pull attract the thing. Okay, yeah. Okay. um, then they give that if we take a stone and a plain paper, which one will reach first? Stone will reach first, because the resistance of the air, that is differ for different material. Okay, resistance of the air will be different for different material. The stone has some weight when compared to the paper, so that the stone will tear the air atmosphere and drop the ground first, will compared to the paper. Okay, yeah. Then for all material, whatever material you draw from the top, it will reach the ground. Whatever material, it will reach the ground at any time, at any day. Okay, yeah. So for all equation of motion for freely falling body, they make an equation of motion for freely falling body. In that you have learned that equation of motion. Equation of motion have three equations, that is V is equal to U plus AT, S equal to UT plus half into AT square, V square is equal to U square plus 2AS. In that V is final velocity, U is initial velocity. In the free falling body, there is no initial velocity at all. There is no initial velocity at all. So that they gave for initial velocity, they gave 0 for the initial velocity. So that the equation become V is equal to GT, S is equal to half into GT square, BC square is equal to 2 into GH. Okay, yeah. Then they gave an activity. See, this is very important. This box is very, very important. What? They asked if a body have 0 velocity as well as finite acceleration. Yes, they told that a body can have a 0 velocity as well as finite acceleration. That is, if you throw a body in a vertical manner, nothing but if you throw a ball in this manner, if you throw a ball in this manner, at the highest point, the ball will go up and it start coming down, isn't it? And it go up and it stop. Where it stop, that is called 0 velocity. And when it start coming down, that is called finite acceleration. I think you understand. Then, if I throw an object, if I throw an object, the acceleration due to gravity become negative for the upward direction. And if it move downward, the acceleration due to gravity become positive, that is plus g. So only they gave minus g as well as plus g. Okay, yeah. Then uniform circular motion. Uniform circular motion. Here they gave an activity, that is take a thread as well as a stone and make by using the thread, rotate the stone and in between rotating, you just leave the thread, and what do you notice? And we can notice that while rotating, we can notice that the stone as well as the thread that move in the straight line. While we are rotating, it is move in the circular direction, and while we are leaving that, it move in a straight line. It move in a straight line. Why this move in a straight line? That we are going to learn. Okay. The stone move in a straight line like tangential to the circular path. Tangential to the circular path. Nothing but, see, I'm going to draw a diagram. A small diagram. This is a circle. This is a circle, and this is called tangent. This is called tangent. What is nothing but tangential? Tangential nothing but a circle. A circle that have a line that touches the circle, that is called tangential. If you are rotating the stone and the thread in this manner, and you are just leaving that and it move like this, in this manner, like this, that is called tangential. Why this move in this manner? That is a question. Because if you draw a circle, and you just focus that circle, you can see that some line is, see, if I'm drawing a circle, this circle have more straight line, straight as well as curved line, more straight. The straight line become curved like that. Okay, yeah. So if I just leave that, leave the thread, and it has also straight line. That the straight line, through that straight line, the thread move outward in a tangential manner. Whether you understand that? See, I am saying in Tamil. இப்போ நம்ம வந்து ரவுண்டு வரைகிறோம். இந்த ரவுண்டு இருக்குது. இப்போ நம்ம வந்து இந்த சுற்றுறோம், அப்படி தானே? நூலையும் கல்லையும் கட்டி நம்ம சுற்றும் போது அந்த சுற்றுறதுல ஒரு ரவுண்டுன்னு சொன்னால் அதில் நிறைய என்ன இருக்கும்னா ஸ்ட்ரைட் லைன் இருக்கும். அந்த நிறைய ஸ்ட்ரைட் லைன் சேர்ந்து தான் அது ரவுண்டாக மாறும். ஓகேயா? அப்போ அந்த ரவுண்டாக மாறுதுன்னா அது இப்போ நம்ம வந்து கயிறை விட்டுட்டோம், அந்த த்ரெட்டை விட்டுட்டோம்னா அதில் ஒரு ஸ்ட்ரைட் லைன் இருக்கும். அந்த ஸ்ட்ரைட் லைன் எந்த வழியில் போதோ அது அப்படியே வெளியே போயிட்டு, அதுதான் என்ன சொல்லுவோம்? tangential அப்படின்னு சொல்லுவோம். Then while rotating, the thread changes direction at every point. Why? Because it has more straight line. It has more and more straight line, and it changes at every point and to make a circular path. When an object is moving with constant speed along a circular path, the velocity changes due to change in direction. Hence, it is called accelerated motion. We know that what is the formula for acceleration? Change in velocity divided by time, isn't it? So, what is accelerated motion is nothing but while we are rotating, while we are moving a thing in a constant speed in a circular direction, the velocity changes. While we are moving a thing with constant speed in a circular direction, the velocity nothing but direction, velocity and direction must change. That is called accelerated motion. Example, revolution of earth. The earth is revolving around the sun. The earth is revolving around the sun in a circular orbit. That is example for this uniform circular motion. For speed, the formula for speed is circumference divided by time taken. Circumference of a circle, that is a formula 2 pi r divided by t. Okay. Then we are going to learn about centripetal acceleration and centripetal force. See this diagram. See, centripetal and centrifugal. There is two topics in that. I'm saying in a simple manner. Wait. What is centrifugal and centripetal? In centripetal, the objects that move through the circular path like to move inward. While in centrifugal, the objects that move in the circular path like to move outward. Okay, and see the topic. Okay. In this centripetal acceleration or centripetal force, like in the uniform circular motion, the object moves in a circular direction and it changes the direction at every point. The motion of the stone in circular path will constant speed and continuous change of direction is an accelerated motion. We know that. What is accelerated motion? That is the change in velocity and direction is called accelerated motion. We have seen the above topic. In centripetal acceleration, the acceleration make the object to move inward. That force is called centripetal force. That acceleration is called centripetal acceleration. And let's see what is centripetal acceleration. That is A is equal to V square divided by R. V is nothing but velocity, R is nothing but radius. And for magnitude of centripetal force is equal to mass into centripetal acceleration. So for the value of mass is small m, centripetal acceleration, that is V square divided by R. See, other centripetal force are gravitational force, frictional force, magnetic force, electrostatic force. The other gravitational force is nothing but other centripetal force is nothing but gravitational force, frictional force, magnetic force and electrostatic force. Okay, I think you understand the centripetal force. Centripetal force, in simple manner we say that the object like to move inward radically. Then centrifugal force. And here a man take a thread and a stone and start rotating in this manner, and the stone like to move outward. That is called centrifugal force. See here, the force that pull away from the center, the force that pull away from the center is experienced. That is called centrifugal force. That is the opposite to the directions of centripetal force. We know that. What is centripetal force? Centripetal force is the object like to move inward, and centrifugal force is the object like to move outward. So it become different. It become opposite, right? It become opposite. So that is called a centripetal force, and it has a the example for centripetal force is washing machine, dryer. If anybody have washing machine in your home, please notice that while you are using dryer, the washing machine will run faster compared to while washing, and the dress that kept in it will move in a circular direction very fastly, and it like to come out. That is called centripetal force. And we know that merry-go-round. What is merry-go-round? Merry-go-round. See, this is merry-go-round. See, the two person who is playing in the merry-go-round, and one person is throwing outside. This is called merry-go-round. Why he is throwing outside? That is due to centripetal force. Okay, that is due to centripetal force. Okay, today we have learned about equations of motion in the previous video. Then motion of freely falling body, uniform circular motion, centripetal acceleration, centripetal force, centrifugal force. Okay, let's take your evolution part, page number 23. Let's take your evolution part, page number 23, and choose the correct answer. Fourth question. The centrifugal forces Option C, virtual force. The centrifugal force is option C, virtual force. If you are not marked the above other questions, please watch my previous video. And for Roman number 6, question number 6. Is the uniform circular motion accelerated? Give reason for your answer. Page number 21. Page number 21. Okay. Mark from when an object is moving to up to accelerated motion. Up to accelerated motion. The next question is, what is mean by uniform circular motion? Give two example of uniform circular motion. Page number 21. Mark from here when an object to up to here, okay. Accelerated motion, up to accelerated motion. Up to accelerated motion. And Roman number 7. Answer in detail. Describe the equation of motion by graphical method. Page number 19 and 20. Page number 19 and 20. The questions start from here. Equation of motion to page number 19 to page number 20. This is the third equation of motion. And explain different type of motion. Question number 2. Explain different type of motion. Page number 15. 1-5. Page number 15. See, from linear motion to above categories. Page number 15. Types of motion, the linear motion to above categories. Okay. And we can see the problems in the next video. I think you have understand the topic what I have teach today. If you have any doubt, please make a comment on it. Thank you, students.